Okay, hello everyone. I am Martin Pielvitori. I have worked a couple of years building the architecture of Game of Code, and here I would like to tell you about one of the last improvements we had in the project, but in a more generic context.
Hello, I'm Federico Motta. I have worked in several projects creating microservices in different technologies. I am currently working as a tech lead on research and development, where we are constantly testing new technologies. Martin?
Okay, yeah, thank you. What you're going to see here. So a lot of memes, of course, but also we are going to talk about the following topics. First, Fede will be giving a review about several microservice architectures with its problem and possible solutions, showing the use case that we use as the basis for implementing gRPC in Game of Code. After that, I will be mentioning the main mechanism that gRPC uses behind the scenes. Then we are going to give you an introduction of how gRPC takes advantage of those mechanisms, adding improvements to the communication between microservices. In the next one, we will show you how the mentioned architectures are implemented with and without gRPC. Finally, Fede is going to share with you some final thoughts. And of course, we will be glad to answer all your questions at the end of this presentation.
So, first of all, what are microservices? Microservices, also known as the microservice architecture, is an architectural style that structures an application as a collection of services. Those are highly maintainable and testable, lastly coupled, independently deployable, organized around business capability, and owned by a small team. The microservice architecture enables the rapid, frequent, and reliable delivery of large, complex applications. It also enables an organization to evolve its technology stacks. But not everything are good news with microservices. As you can see here, they have some drawbacks. The drawbacks are just challenges to overcome, mostly related with the complexity of the resultant application. Those challenges are the design complexity, communication problems between the microservices, redundant calls between microservices, and also security, because you have a lot of microservices. So we have here an example that we will use later as a use case. And you can see, for example, that we have a front-end, we have 4 microservices. And for example, if we want to make a request to user API to retrieve data, it should connect or from the front-end or the user API itself. It should connect to the other microservices, and it's really a mess. So what can we do to fix this? Good practices, for example, using design patterns, are the best way to fix this problem. So we have already an application, and what's the first improve to make to our microservice application? This is the backend from frontend pattern. What is a BFF? Backend from frontend is a design pattern created with not only the developer, but more important, the user and the user experience in mind. It is the answer to the ever-growing adoption of application to meet, interact, and serve customer, ensuring consistency while still meeting the diverse and evolving needs. What are the good with this? They are easier to maintain and modify API. You have better error handling because they are all handled in one place. You have improved security, and you can also have multiple backend for frontend. For example, if you have an application that receives data for web or for mobile, you can create 2 different backend for frontend. It's not this example I'm showing, but you can follow the idea. You can add another backend for frontend. So basically we change our code, our architecture to add a new service, a backend for frontend here. You can see that all the traffic is received only here, and from here you handle all the other connections. What this means that you can move all these microservices to a secure network without access from internet and just exposing this API. Also, you can lose the couple idea because you can retrieve data to the front end, mixing all the other microservices. And your front-end developer shouldn't create a lot of for each, mixing all the data here. You just make all the work here. Okay? Next. So we added a backend from frontend, an improvement. Because of this, we improve our code, our architecture. As we said, we added more security. We simplified the design of our application and the code itself. But we can still make more improvement to our app. One of them is using gRPC. What is gRPC? gRPC is a modern open source high performance remote procedure call framework, sorry, too long, that can run in any environment. It can efficiently connect services in across data centers with pluggable support for load balancing, tracing, health checking, and authentication. It is also applicable in last mile of distributed computing to connect the devices, mobile application, and browsers to backend services. We will continue to explain in detail this. This is just the definition, but I can say that it improves the security, it removes redundancy of data, and as a plus, it improves the performance of our application. Martin?
Okay, yeah, thank you. Now we are going to talk a little bit about the different mechanisms that gRPC uses internally. The first one is RPC. In distributed computing, a remote procedure call is when a computer program causes a procedure to execute on another computer on a shared network, which is called as if it were a local procedure call without the programmer explicitly coding the details for the remote interaction. And following the diagram, an RPC is initiated by the client, which sends a request message to a known remote server to execute a specific procedure with supplied parameters. And the stub is the principal actor here, where it's marshal all the parameters and send between the server and the client during this remote procedure call. There are 4 different types of RPC. The first one, the unary, is the simplest form of RPC. In this case, the client sends a request message to the server and receives a response. In this case, no streaming advantage. Then the other one, server streaming. In this scenario, the client sends a request message to the server and receives a sequence of responses. So it's a server to client streaming. On the other way, the client streaming is the case where the client sends a sequence of messages and receives a single response from the server. This means client to server streaming. And the last one, bidirectional streaming, is a case where the client and the server exchange messages in both directions. Well, this is another important thing. It's where it's the basis of that you say gRPC, because HTTP2 improves a lot the communication. It seeks to address some of the scalability problem of HTTP1. It increases network efficiency, enables real-time communication, provides stream with persistent connection, and also has server push, header compression, and binary form. The key differences HTTP2 has to HTTP1 are as follows. It is binary instead of textual. It is fully multiplexed instead of order and blocking with limited number of requests. It uses header compression to reduce the overhead. It allows server pushing to add responses proactively into the client cache. And also it can use one connection for doing parallelism. This brings us several benefits, such as efficiency over the network, less error prone, reduced security concerns, parallelism using the one single TCP connection, etc. Okay, let's see how multiplexing works over the network. In this demo, we can see how multiplexing works by loading two images. Each image is split in almost 400 small tiles, causing almost 400 separate connections to be made to the server. The first one creates all those connections, so you can see that it's really slow. And with HTTP2, it causes only one TCP connection, so it's a lot more faster. You can see 30 seconds against 4. Okay, now, so we explain some basic concepts related to microservices, drawbacks and good practices, the difference between communication protocols, and now we will explain briefly gRPC. Okay, for you to know, gRPC was open source from Google in 2015, and later joined the Cloud Native Computer Foundation. And as I said, gRPC is a modern open source, high-performance remote procedure call framework, an evolution of inter-process communication. It uses protobuf and message contracts to create high-performance, close to real-time services. It can run in any environment, efficiently connecting services in and across data centers with pluggable support for load balancing, tracing, health checking, and authentication. It is a low-level protocol, full bidirectional, with tools that create code to make client and server services. And as we said, RPC is a form of client-server communication that uses a function call rather than a usual HTTP call. That means services references, no paths. Okay, the main reason. The performance improvements there are more reasons for sure, but the two most important improvements according to our criteria are data serialization, where in the case of gRPC, is based on a compiled ad hoc parser that produces a smaller and therefore faster payload. And the streaming, that with one TCP connection, many messages, full bidirectional, so no more stateless. To finish the introduction of gRPC, we review the workflow of how the framework works. First, when we compile the protofile, the compiler generates the code in any language, including getting and setting fields, and serializing our messages to an output stream, and parsing our messages from an input stream. Okay, now we are going to talk about API specification. Yeah, I know, another technical boring section. OpenAPI. Okay, Swagger or OpenAPI and gRPC protobuf are two approaches to building networking APIs. In the case of OpenAPI specification, or its precursor Swagger, it is a structured way of describing REST APIs using YAML or JSON that was originally created to better document APIs. Instead of this, gRPC are serialized using protobuf as an efficient binary message format. Protobuf serializes very quickly on the server and client with less error than textual payload, so less error prone. The binary results are small. Yeah, by the way, Proto 3 is the latest version of protobuffer syntax. Now we are going to see a couple of protobuf examples in order to show you how it is implemented. As we can see here, a service has RPC methods, no verbs. Protocol buffer messages define structured objects, parsed in a specific structure with the specific fields with their specific types you expect. So less flexible than JSON, but this strong specification is one of the benefits of protobuf, strong validation and quick binary serialization. It is important to have in mind that protobuffer files will be compiled in an optimized version. In our case, we compile on the fly. Okay, here is an example of sending a message without the parameters, because we always have to define a message in RPC. So to do that, protobuf allows you to have an empty message or response by using Google protobuf.empty. The other one, the arrays, we use equivalent to arrays, we use repeated in order to indicate that we are going to send a list or a collection. Okay. The idea of protobuf is to describe the data structure in programming language and platform neutral way. And here we can see that we can specify different files rules like required, that means exactly one of the fields, optional, meaning 0 or none of the field, repeated, that is that we saw in the previous slide. And yeah, that's it.
So at this point, we already explained all the gRPC theory, the difference between the communication protocols, and some basic knowledge about microservices and the BFF pattern. Now we are going to show you a real example. We will show you some code and we will demonstrate how much our application performance will be improved. I think this is the fun part. So let's talk about our application that we are creating. We have several microservices, in this case, 4: skills, education, users, and out. Each of one, it has some parameters, data. We added a backend for frontend because we already know that this is the best approach. And the frontend will request directly to the backend from frontend. We can see that we are using REST. And we are trying to move from this example to this example. Very similar, as you can see. The only difference is we are using gRPC in the backend. So first of all, we have here the API definition of the get all users endpoint. As Martin said, we are using Swagger. I think is the best approach, using design first, trying to design first the application. And this tool is very useful for that because you design the application, and also with some plugins we can plug and have a result in your code. For our example, we have, as I said, get all users in the backend from frontend, the get verb, and the response is retrieving all the user data, connecting with the other microservices. Remember that this is happening because we have a backend for frontend. If we use without the backend for frontend, the get all users will retrieve only ID, first name, last name, email, and nothing else. You should take care of the connection with the other microservices. But in this case, we are adding the object for skills, for education, and another data there, right? So now Martin is going to show you a little bit our implementation in Node. I am going to stop sharing screen. Martin, we will share the screen for you.
Okay, thank you. Okay. Here we have our implementation. It's a simplify of the use case, the real use case, because the real use case has a lot of complexity that is not matter of this talk. So here we have the Docker Compose in order to run it locally with all the different microservices. All the data is going through an Nginx, and we have also the database. Then the principal endpoint of the BFF controller, we are using first, we are using Express. We expose the root of the users. And here we have the implementation of the controller. Here, the principle that we are using here, that the principal difference that we are going to change with gRPC is that here we instantiate an HTTP client, and we call all the microservices against HTTP, so REST. Here, in order to get all the users, the different pages of the users, because the microservice of users return pages of the users. We have to make several calls, but we also add the improvement that Fede said, is parallelizing all the requests. So here we have the parallelizing of the requests of all the pages. In one moment, we parallelize all the requests, but then we have to create all the promises in order to get all the other user data, and all the requests are over HTTP1. So that is something that we saw that we could improve. And then, for example, to show you how it's implemented, the microservice is just a simple controller that calls the database and return the page with the received parameters. And here is the cool thing, that in order to migrate this from REST to gRPC, you don't have to change a lot. You don't have to refactor a lot of code. So I'm going to show you the controller, the BFF, where we are using here the gRPC client. We separate this into a helper in order to simplify the code. But here, the thing that you have to do is to compile the proto file and to create the client. It's written on the client, and on the controller we create a promise in order to await to the response. But then it's pretty similar, the error handling and the way to get the data. And the main change here is that we are using server streaming, and we call to get all the users with this snippet that we use event. So we are receiving all the server response and concatenated into a response, and then we will use it. But this is only one TCP connection. That is really fast. And then, of course, we use gRPC in the other services, but without streaming advantage. And of course, users is the way that we implement the RPC server. First, you have to initiate the gRPC server. That is really simple. It's not too much complexity. You have to compile the protobuf file the same way as the client, then instantiate the server, add the service, and binding the ports and the host. It's really easy. And on the service, it's quite the same. Not here because it's streaming, but for example, this one, the only difference between gRPC and REST is the object that you receive and use to retrieve the data. We receive a call instead of request and get the parameters from there. You will get also the metadata in gRPC, and the response will be on the callback. And in the server streaming, with call, we are going to write all the pages. Here is we are just writing all the users, iterating in those that collection, but it's just a simple example. But you will retrieve all the data that you get from the database from pages, for example. Another thing that we are using here, we are using a volume because we are using locally. So we are sharing all the protobuffer into a volume. So we define all the protobuffer into a volume, and we share between all the microservices. But on the production example in Game of Code, we create a library with each proto buffer file. We create a library and publish into the registry. So we use each proto buffer file as a dependency of each microservice. So we put the library in only one place. Okay, that is fair. People continue.
Okay, I'm going to share my screen again. So we have an example here.
Okay, yeah. Here we will see the productive case we implemented in Game of Code. In this case, the BFS was calling several microservices, and one of them had a lot of records needed to get the required data. The first two requests were with REST, and the last two with gRPC, using server streaming in one of the internal calls. It's an edge example because it has a lot of records, but you could see that the improvement is really, really considerable.
So we are almost done. What we achieved in this workshop? This is a recap, right? We created a REST API with the backend from Frontend and using gRPC in the backend communication. Because of this, we added an extra layer of security. The services and ports are available from the internal network only, not accessible from internet. The security concerns associated with textual attacks, such as splitting, are no longer relevant. We take advantage of RPC using server streaming. The data is being retrieved in parallel with a single TCP connection, as Martin explained. And the response time was improved considerably. And you can see the example that we show you about a real life example for Game of Code. So what are the next steps if we want to continue to evolve our application and the performance? We have these 3 points. You remember that Martin told you about the proto files are compiled on the fly. You can test what happens if you compile them, not on the fly, and see the performance. We didn't do that, so it's a test and then go to the best way. Another improvement could be using a gRPC gateway. It means that if you remember in the graph I show you, there is still a REST connection. This means moving this REST connection from the front end to the backend for front end and using gRPC there also. We have an example here to show you. The last performance improvement could be using gRPC in the browser. Unfortunately, this is not ready yet. This is still in development. The people working on this, they are still working on the best way to use gRPC directly in the browser. And I think That's it. Do you have any questions? We are glad to answer any question.
Yeah, I believe that no, there is no any question.
Okay.
We could wait a couple of minutes, but yeah, if not, we will continue. Okay. No, there is any question.
Okay.
Okay. Thank you all. If you have any doubts, if you want to talk about gRPC or the way to implement, we are researching, we are testing it, so feel free to contact us. There you have our email. So thank you all.
Thank you. Thank you very much.